Since time immemorial, the red planet has sparked curiosity and wonder in the human mind. This distant world, with its rouge landscapes and dusty plains, has inspired countless tales and theories. Yet, as we edge closer to the reality of setting foot on Mars, we must grapple with the practicalities of surviving in such a hostile environment. One of the key challenges we face is oxygen production. On Earth, we take our breathable air for granted. On Mars, however, the thin, carbon dioxide-rich atmosphere is far from hospitable. NASA, among others, is turning this problem into an opportunity. Through innovative technologies and strategies, they're planning to extract oxygen from Mars's atmosphere, a crucial step towards sustaining human life there. But the journey isn't straightforward. There are significant obstacles to overcome, from technical complexities to the sheer unpredictability of an alien world. The question remains, how will we breathe on this alien world? To understand the challenge, we must first understand Mars's atmosphere. Mars, our red neighbor, has an atmosphere vastly different from ours. It's thin, about 100 times less dense than Earth's, and composed primarily of carbon dioxide, with only trace amounts of oxygen. This means that humans cannot breathe the Martian air. Now compare this to our home, where our atmosphere is a life-supporting cocktail of nitrogen and oxygen. The stark contrast highlights the significance of oxygen for our survival on any planet, including Mars. So if we're to make Mars our second home, we need to figure out a way to get oxygen there. And not just for breathing. Oxygen is also a crucial component in rocket fuel, making it essential for return trips. The thin, oxygen-starved atmosphere of Mars presents a formidable challenge for human survival. The International Space Station provides invaluable lessons on sustaining life in space. It's a floating laboratory, a home away from home for astronauts, and it's been continuously occupied for over 2 decades. One of its most critical functions, providing oxygen and water for its inhabitants. The station uses a complex system to supply these necessities. The Water Reclamation System, or WRS, is a marvel of modern engineering. It recycles nearly all of the water on board. Yes, that includes sweat, humidity from the air, and even urine. The purified water is then used for drinking and rehydrating food. But it also plays a vital role in oxygen production. That's where the Oxygen Generation System, or OGS, comes in. The OGS uses a process called electrolysis to split water into its 2 basic components, hydrogen and oxygen. The oxygen is then circulated throughout the station for the crew to breathe. But here's the thing, Mars isn't the ISS. The station orbits Earth within the safety of our planet's magnetic field, shielded from the worst of space's radiation. Mars, on the other hand, has a thin atmosphere and no global magnetic field to speak of. Plus, the ISS has regular supply runs from Earth. Mars will not. So while we can learn from the ISS, we can't just copy and paste its life support systems onto Mars. The red planet presents its own unique challenges. Its thin atmosphere is mostly carbon dioxide, with just a trace amount of oxygen. That's a far cry from the breathable 21% oxygen in Earth's atmosphere. And while Mars does have water, it's mostly frozen in the polar ice caps or mixed with the soil. Extracting it will be a challenge in itself, not to mention the difficulty of setting up and maintaining complex systems in a harsh and distant environment. So as we look towards Mars, we take the lessons of the ISS with us. But we also understand that we're stepping into uncharted territory. The solutions that work in the orbit of Earth may not work on the surface of Mars. NASA has been actively researching and experimenting with solutions to the oxygen problem on Mars. One of the most promising methods is a technology called MOXIE, the Mars Oxygen In-Situ Resource Utilization Experiment. This device, which is currently aboard the Perseverance rover on Mars, is designed to convert the carbon dioxide in the Martian atmosphere into oxygen. The process, known as electrolysis, works by passing an electric current through carbon dioxide, splitting it into oxygen and carbon monoxide. In a series of tests, MOXIE has successfully managed to produce oxygen at a rate of about 6 grams per hour, a small but significant step towards making Mars habitable for humans. Another potential method for oxygen generation on Mars involves the use of algae or bacteria. These organisms, which produce oxygen as a byproduct of photosynthesis, could be genetically engineered to survive in the harsh Martian environment. This approach, however, presents its own set of challenges, such as the need for water and sunlight and the risk of contamination. NASA is also considering the use of chemical reactions to generate oxygen. For instance, water ice, which is abundant on Mars, could be split into hydrogen and oxygen through a process called electrolysis. This oxygen could then be stored for future use, while the hydrogen could be used to create fuel for rockets. However, implementing these oxygen production systems on Mars is no easy task. The thin Martian atmosphere, the extremely cold temperatures, and the lack of available resources all pose significant challenges. Not to mention, these systems would need to be self-sustaining and capable of operating remotely, as human intervention would be minimal, if at all possible. Despite these complexities, NASA's approach to oxygen production on Mars is a testament to human ingenuity and determination. It's a reminder that even the most daunting of challenges can be overcome with the right combination of science, technology, and sheer willpower. While the task is daunting, the ingenuity of scientists and engineers gives us hope. With every successful experiment and every new discovery, we come one step closer to turning the dream of Mars colonization into a reality. The journey to Mars is fraught with challenges and risks. While the red planet has been a subject of fascination for centuries, the reality of putting humans on its surface is a complex endeavor that extends far beyond just getting there. The very act of sustaining human life on Mars, particularly the production of breathable oxygen, presents a myriad of challenges and potential hazards that must be addressed before we even set foot on Martian soil. One of the most significant hurdles is the Martian atmosphere itself. It's thin, with less than 1% of Earth's atmospheric pressure, and it's primarily composed of carbon dioxide, with only trace amounts of oxygen. This makes creating a sustainable oxygen supply for human inhabitants a monumental task. Adding to this are the potential disasters that could occur. Equipment failure, natural Martian phenomena like dust storms, and even the risk of an extinction-level event such as a meteor strike, all pose substantial risks. Each of these scenarios could drastically impact our ability to produce oxygen, threatening the lives of those on Mars and potentially stranding them millions of miles away from home. But it's not all doom and gloom. The challenges we face in colonizing Mars also present opportunities to learn and grow. We can take lessons from our own history, particularly our experiences with climate change, and apply them to our efforts on Mars. How we've managed our own atmosphere, how we've dealt with environmental crises, and how we've adapted and innovated in the face of adversity, all hold valuable insights for our Martian endeavors. Addressing these challenges and risks is not just about survival, it's about the evolution of humanity. It's about learning to adapt, to innovate, and to overcome. It's about pushing the boundaries of what's possible. The stakes are high, but the rewards could be astronomical. Our journey to Mars, as challenging as it may be, could mark a new chapter in human history, a testament to our resilience, ingenuity, and unending curiosity. The future of Mars exploration is on the horizon. Visionaries like Elon Musk have grand plans for colonizing the red planet. Musk's SpaceX aims to send its first crewed mission to Mars in the mid-2020s, with the long-term goal of establishing a self-sustaining colony. But SpaceX isn't alone in this race. Other space agencies across the globe are also setting their sights on Mars, with various timelines projected for the next couple of decades. As we look ahead, we can anticipate advancements in technology that will aid in oxygen production on Mars. Innovations in chemical processes, bioengineering, and even nanotechnology could potentially revolutionize how we generate and store oxygen on the Martian surface. These developments are not just about reaching Mars, they're about setting up home there. The race to Mars is not just about getting there, but also about surviving there. The journey to Mars is not a simple voyage, but a complex mission. It's a puzzle with many pieces, each as crucial as the next. Oxygen production, a seemingly mundane aspect of life here on Earth, becomes a monumental task when we speak of Mars. It's more than just providing air to breathe. It's about fuel for rockets, water for astronauts, and a stepping stone to self-sustaining colonies on the red planet. The challenges and risks are significant. From the thin Martian atmosphere to potential disasters and extinction events, each hurdle requires careful planning, innovative engineering, and a hefty dose of courage. We've learned from our home planet that survival is a delicate balance, a lesson that rings true even millions of miles away. As we stand on the brink of becoming an interplanetary species, the question remains, will we conquer Mars or will Mars conquer us?